5. So as usual, the first thing you should do is pull up the tasks to complete for today. You should be able to find it under assignments, tasks for U2L5, or on the campus homepage on the weekly calendar right by today's date, which is the 27th of October. Pretty crazy. This month is rolling by. As usual, we will start off with a little breakout room session and silly question. So take some time to say hi to the person you're put with and chat with them, but then at some point share your answer to this question. It's in the chat right now. If you had a time machine, would you go back in time or into the future, and why? I'm gonna give you 20 seconds to think about it, then pair you up. All right, we'll come back together in 2 minutes. Rooms are open. Make sure that you've completed the how far can you throw Flipgrid. I'm seeing 11 responses to that. So if anyone has not completed that yet, please, you just need to film yourself doing one of each throw. One balled up sock, one loose sock, that's it. And then there's a quiz associated with that too that I'll be grading soon. You also had to do the PhET simulation quiz. And the key takeaway on that one was that if we're assuming there's no drag and that the projectile is landing at the same elevation that it was fired from, what can you always, if you have two angles that add up to 90, what's going to be true about where that projectile lands? So if I fired at like 45 and 45, Ronan?
They'll land in the same spot.
Yeah. But again, there's a lot of ifs, right? In terms of same elevation, and air drag throws all that off. And did anyone get why they put the statue of David at the base of their little cannon in this little simulation? Who knows their Bible? Come on, someone's got to know their Bible. So the
Wait,
statue,
is this the giant killing David? Is it that guy?
so it is a reference
because he threw the stone and killed the giant.
Yes. So David, what was the giant's name? David and
Goliath.
So David and Goliath, right? And the statue of David, if you actually look at the statue of David, he has his arm up kind of over his shoulder. And has anyone been to Florence and seen the David? I'll say quite a few of you. It's a sling he has over his shoulder. It's a little leather strap that he was throwing a rock with. And so it's a projectile, right? So that's why they put him in there. Anyway, it took me a while to figure that out too. At first I thought, oh, it's just like a figurine or something, but I was like, there's gotta be a reason they put that in there. And then it kind of hit me, so cool. And then there was the Hewitt chapter 5.12 reading quiz. Results look really good on Canvas. Were there any questions or anything you found confusing on that? Alrighty. Then the next thing we're going to do is watch a little animation together, and I'm going to send you off to work on, one more thing I wanted to get to real quick was the Canvas reminders, because I've been getting a few questions from students about where to look if you're looking for like, the recording of our lesson, or if you want to know your grades. And so I just want to quickly remind you that on Canvas, as you can see on my screen now, and I know you don't always have this course view, but the point is if you go to the Science2 hate page on Canvas, there's two things I'd like to point out. The first is the weekly calendar. If you haven't checked this out yet, please do. Just on the homepage, all you have to do is scroll down, and you'll see here that there are links in every single column. The plan link for every lesson is the tasks to complete. So it'll always take you to the tasks to complete for that lesson. And below that are links to videos. And I've been recording every single lesson. That's where I tend to put these. I'm a little behind right now in posting the videos, but I will get caught up as soon as I can. But you can always find those there if you didn't know that. The other thing is the grades tab. So over here on the left, you'll see there's home, announcements, assignments, discussions, and grades. If you click on grades, it'll pull up your little transcript. I won't do that because it doesn't pull up a transcript for me, it pulls up everybody. But it'll pull up your assignments. It shows you what's missing, shows you notes from me. And if you scroll all the way to the bottom, you can see your grade as it currently stands. And I'll keep entering things as we go, but just want to remind people of that. Okay, next task I wanted to do real quick was a little introduction to Orbit using a Google form. We're gonna watch a 40-second clip from Family Guy really quick here, and then you're gonna answer some questions based on it. I'm gonna optimize for sharing. here we go.
Peter, I think maybe you're in denial about this fat thing.
Oh, yeah? Well, I challenge you to prove to me that I'm fat.
Okay, hang on. See this?
Yeah?
You know what it is?
Duh, it's an apple.
Good, good, good. All right, watch this.
What the hell? What is this? What is this, some kind of gag?
No, that's orbit.
Huh?
You have your own gravitational pull.
Oh, that's a bunch of crap.
Now back to the Three Stooges.
Aw. Aw.
All right. So now what you'll be doing is on step number, step number 4, Introduction to Orbit. There is a link to a Google form, Intro to Gravity Family Guy clip Google form. You can watch the clip again if you need to. I'm going to give you 5 minutes to work on that Google form based on that short clip. Go for it. Let me know if you have questions. And the circumference of a circle, which you're going to have to do for your orbit drawing activity. We're going to use a dot right here to represent a star, and we'll have planets orbiting around it. This could be a planet with moons orbiting around it as well. But we have elliptical orbits and circular orbits is what we've learned about. So for an elliptical orbit, the star is one focus, but there's another focus, and for the activity you're going to draw it a little bit below the star there. Now in space there's nothing there, it's just another center of gravity. The gravity is coming from the star entirely. But to draw an ellipse around that, you'll see in the activity how you do it, but an ellipse is essentially sort of a stretched out circle from that point. And so I'll draw it looking like this. Again, not perfect ellipse, but clearly not a circular orbit either. So the eccentricity is a measure of how circular your ellipse is. So eccentricity, and we calculate it as E equals C over A. And so the C value, the first thing you need to do is find the center, which in this case is the halfway point between the star and this gravitational point. So I'll draw that right there. That's the center of our ellipse. Not the center of our gravity, though. Remember, the star is the center of our gravity, but that's the center of the ellipse. The C value then, right here, is the distance from the center to one of the focus points. That's your C value. The A value down here on the bottom is a larger number. It's the distance from the center point to the outermost point of the ellipse. That's your A value. So you got to find that center point between the two foci, measure the distance from the center point to the outermost edge, and measure the distance from the center point to one of the focus points. Doesn't matter which one, they should be equidistant. And the point is that you're going to have a small number divided by a large number, which will give you something below 1, right? It'll give you 0 point something. Circles have an eccentricity of 0. Circles equal 0. And so the closer to 0, the rounder or the more circular the ellipse is. And less close to 0 means it is more elliptical. Okay. A circle is just evenly spaced from, again, you're drawing from your star point right there. And so I'll do my best to sort of draw just a wide circle here, encasing that. And for the circle, you're going to have to find what's called the circumference. And I'm sure a lot of you are familiar with this. Circumference is just calculated as 2 pi r. Pi is 3.14. R stands for radius, which is just the distance from the center point to any edge of the circle. That's your radius. So all you got to do is measure that, do 2 pi r, and you've calculated the circumference. Notice that eccentricity will not have a unit on it because it's a ratio. So if you measured in centimeters or inches, it doesn't matter as long as they cancel out. There's no unit on eccentricity. But for circumference, you will have a unit. It's whatever you use to measure the radius. So if you measure it in centimeters, your circumference will be in centimeters. If you measure radius in inches, your circumference will be in inches. All right. And I've got a little explanation on the tasks list that you can see. So I'm now going to give you 20 minutes to work on the drawing activity, which is listed as step number 6 right there, drawing orbits. And it'll walk you through everything. It's got instructions. I have a longer demonstration video, which you're welcome to kind of play through, but you're going to be trying to draw on a sheet of paper an elliptical orbit and a circular orbit, and calculating the eccentricity and circumference. And again, the assignment will walk you through everything. So I'm going to time for 20 minutes. I'll be here if you have questions. If you're not sure how to do something, you are going to need push pins and a few other things. So just let me know if you need help, and we'll check back in 20 minutes. If you manage to finish before 20 minutes is up, you're welcome to move on to the next task, which is a online simulation of orbit that you can explore. It's pretty simple. Okay, go for it.